Hello, 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 my fellow mathletes. We're looking now at question number 6. Question 6 on the 2008 Grade 12 Manitoba contest. So question 6, a racetrack is built with 2 straight parallel sides and semicircles at the ends as in the figure. The parallel sides are 100 meters long and 100 over pi meters apart. Interesting. I guess they're trying to make it so we can do circumferences or areas of these semicircles without too much difficulty. Runner alpha at position A starts running clockwise, around the track at 2 meters per second. At this precise moment, a second runner, beta, enters the track at position B, which is 100 meters from position A, running at 5 meters per second. If beta wants to meet alpha as soon as possible, should he run clockwise or counterclockwise around the track to achieve his goal? So we sort of have 2 computations to make. If beta chooses to run clockwise, well, he's competing with the fact that A is also running clockwise. So effectively, B is catching up to A at the difference of their speeds, 5 meters minus 2 meters, so it'll be 3 meters per second. So in order to catch up to alpha, beta has to cover 100 meters running at 3 meters per second, effectively. But if beta chooses to run counterclockwise, then they're both coming around together. And so if we just imagine that we are sort of riding on A's shoulder, and sort of think of it like you're in a car. When you're in a car, you don't feel like you're moving. You just see the world moving and whizzing past you. So if you imagine you're on A's shoulder, the world is stationary to you, and you see B approaching because you guys are coming at each other. And B is effectively approaching you, covering the distance to you at a combined speed, because you're running towards him, he's running towards you, at 5 meters plus 2 meters, so 7 meters per second. So while in their picture it looks like beta has a longer distance to get to A, beta will also be running at more than twice the relative speed, as if he was chasing A clockwise. So we still have to do both these computations, but that's the way to think about this. Okay, so first notice that if beta runs clockwise, he must cover 100 meters to alpha at a speed of 5 meters per second minus 2 meters per second. And if you want to, you can explain this, but I think the difference in speed is quite clear. So 100 meters needs to be covered at a distance of 3 meters at a speed of 3 meters per second. This takes time. Well, time is distance over speed, the distance you want to go, how fast you're going, and that's going to be 100 over 3 seconds. So just for comparison purposes, that's about 33.3 seconds. Okay. If beta runs counterclockwise, so we've got, I don't know why they gave us the track like this when they could have given us a full circle. It doesn't really matter. I guess it's just trying to make the question a little harder perceptionally. So we get 100 meters here, 100 meters here, and then we have these 2 semicircular arcs. Now combined, they make a full semicircle with diameter 100 over pi. So semicircular arcs. So circumference is pi times the diameter. So together they are 100 meters. If beta runs clockwise, so he starts here, has to go here, plus 100 meters, and then this is the rest of the semicircular arcs together, so he has to cover 200 meters. At an effective speed of 5 meters per second that he's running, but alpha is essentially covering that distance as well. So 7 meters per second. And if you want to, you could make a sentence explaining this, but adding and subtracting speeds relative to each other is a fairly common thing to do. This takes, how long does this take? So time t, 200 meters at 7 meters per second. That's going to be 200 over 7 seconds. Okay, now I don't quite have a good approximation of this in mind, but we need to know who's got the shorter time. So beta wants to minimize time. So 100 over 3. So we want to compare 100 over 3 and 200 over 7. One thing you could do, most people will do this, I would guess, get a common denominator. So this is 700 over 21, and this is 600 over 21. And so, this one's bigger, because the numerator, when you have a common denominator, you can just compare numerators. And so this is the bigger time, so he wants to run, beta should run clockwise, run counterclockwise. That's fine. Common denominator is fine as well. But another thing you can do, get a common numerator, and I think that's a little easier. Okay, but when you have a common numerator, you can compare the denominators, but use the opposite sign, and that'll tell you how the fractions relate. So 7 greater than 6, so the fraction with the 7 is less than the fraction with the 6. That's another way to see it. Common numerators is fine. When you divide by numbers, dividing the same number by 2 different numbers, the bigger number will make it smaller. It breaks it into smaller pieces. Okay. However you do it, we realize that 100 over 3 is greater than 200 over 7. So beta should run counterclockwise. I don't know why I keep saying clockwise. Beta should run counterclockwise. He'll get to alpha slightly faster. A full 100 over 21 seconds faster. So that's, what, a little more than 4 seconds? That's not bad. Actually, no, it's a little less than 5 seconds, so quite the time save. Anyway, that wraps up question number 6, and in the next video, we're going to take a look at question number 7. So thank you guys, as always, for watching, and I will see you next time.